Welcome students. In this section, I am going to discuss about a resistor. Resistors are found everywhere and are used in almost every electronic circuits, devices and projects. There are many different types of resistors available in the market having different properties and used in so many different ways in different types of circuits. Due to its high demand, every month millions of students and professionals belonging to different fields of electrical and electronics engineering search about the resistor to learn something that can be practically implemented while designing any electronic circuit. A resistor is an electrical component that limits the flow of electric current. The unit of resistor is ohm. Resistance is the property of a resistor whose value depends on the length, resistance of the material, and its cross-sectional area. R equal to rho L divided by A. The symbol of the resistors are given by IEEE and IEC. Type of resistor. Resistors are generally classified into two types: linear resistor and nonlinear resistor. Linear resistors is one of the most commonly used resistors. This resistance of the linear resistor remains constant even if the potential difference of the voltage applied is increased or decreased. They have a fixed resistance which does not change. Linear resistors has further two types that have linear properties. First one, fixed resistor and variable resistors. The majority of the resistors used in electronic circuits are fixed resistors. These resistors which has a fixed resistance value, it is not possible to change or vary the resistance value. Fixed resistors are available in various sizes and shapes. Most commonly used fixed resistors are 1 kilo ohm, 100 ohm, 10 kilo ohm and 330 ohm. There are four types of fixed resistors. First one, carbon composition resistors. Second one, wire wound resistor. Third one, thin film resistors. And thick one, thick film resistors. Coming to the variable resistor. In the variable resistor, the resistors can be changed manually by rotating the knob. This type of resistor are used in tuned circuits. These resistors have mostly 3D legs. The rightmost and leftmost legs of the variable resistor are connected with the voltage and ground. We get the voltage on the middle leg of the variable resistor. This is nothing but a voltage divider. There are three types of variable resistor: potentiometer, resistors, and trimmer resistors. Now we see a nonlinear resistor. Here the flow of current changes with a change in temperature or the applied voltage. There are four types of nonlinear resistor: thermistor, resistor, LDR and flexible resistor. 0 ohm resistor. It is clear from the name 0 ohm resistor that this type resistor which have almost no resistance. In reality, this resistance is not 100% zero. That is 0 ohms and it offers very small resistance. You may ask why we need a resistor which has a resistance equal to 0. Rather than using a 0 ohm resistor, why not use normal jumper wire? Now I will explain. The 0 ohm resistor are used in PCB manufacturing companies. As you know, today the components in printed circuit boards are inserted by automatic insertion machines to speed up the manufacturing process rather than manually by humans. For jumper wires, a separate machine may be needed or this wire should be manually inserted by humans. So we use 0 ohm resistors. These resistors can be easily removed and can be easily replaced with other resistors if needed. We already studied this resistor color coding in school days itself. The colors in the resistor are black, brown, red, orange, yellow, green, blue, violet, grey, white. Now I explain how to find the values of resistors using the color code. Here we have a 4-band resistor. In the first 2 band indicates a color value, third band is a multiplier, fourth band is a tolerance band. Similarly, in the 5-band resistor, first 3 band indicates a color value, fourth band is a multiplier, and the fifth band is a tolerance band. There are a lot of websites to calculate the resistance value. Now I explain how to calculate the resistor value in real time. Here I choose the number of bands and colors. For example, I select 4 band and choosing the colors. For band 1, brown, band 2, black, band 3, red, and tolerance, gold, band 4. We get the values as 1 kilo ohms with 5% tolerance. Resistor value calculation in real-time application. The circuit shown here consists of a LED connected in series with a resistor and battery. V is the voltage of the battery. Vf is the forward voltage of LED. If is the forward continuous current. Using datasheet for 5 super bright LED, I found the values of Vf and If. Vf 2, this is a typical forward voltage of LED, and forward continuous current is 20 milliampere. To find the values of resistor, the formula is Rs equal to V minus Vf divided by If. So V is of battery voltage 9 minus forward voltage of the LED 2 divided by forward continuous current is 20 milliampere. So the value of Rx is 350 ohm. Using simulation, I will show the resistor value is correct. Now I open the software and I am choosing 9-volt battery and place it in the workspace. I name the battery as 9-volt. Then I choose a LED and bring it to the workspace. We can choose any color for the LED. Here I choose red color. Now I am connecting the anode of LED to the positive of the battery and cathode to the negative of the battery. Then I change the color of the wire for identification. Now I simulate the circuit. The LED get damaged because the forward conduction current flowing through the LED is 950 milliampere. But as per data sheet, only 20 milliampere forward conduction current should be flow through this circuit. Now I am going to connect a 350 ohm resistor in series with a battery and LED. And I am going to start the simulation. LED glows. For current measurement purpose, I am connecting a multimeter in series with a battery and resistor. Another multimeter is connected across the LED To measure the voltage, now I start the simulation. Three things are proved. First, LED is glowing and resistor value is correct. Second, forward conduction current is 19.7 milliampere, approximately 20 milliampere as per the data sheet. And the third, forward voltage LED is 2.07 volt. How to choose power rating of a resistor? The resistors generally available in quarter watts, half watts, 1 watts, 2 watts, 5 watts and 10 watts. The formula to find the power is V squared by R. Here I consider the supply voltage is 9 volt and resistor value is 350 ohm. On solving, the power is equal to 0.231 watts. So approximately 0.25 watts. So we can choose 350 ohm resistor with quarter watts rating. Series and parallel connection. When the resistors are connected in series, the equivalent resistance is R1 plus R2. When they are in parallel, the equivalent resistance is 1 by R1 plus 1 by R2. Problem 1. In the circuit given below, the value of R required for the transfer of maximum power to the load having a resistance of 3 ohm is. The answer is 0. Now we see the solution. If I choose R 0, then the equivalent resistance becomes 0. Then maximum power is transferred to the load. Next problem. In the circuit shown below, the voltage and current sources are ideal. The voltage across the current source in volts. The answer is 20 volt. Solution. The current 5 ampere is flowing through the resistor. So the voltage across the resistor is 10 volt. Current entering point of the resistor is positive and other end is negative. Therefore, two sources gets added. 10 volt from source and another one is from voltage across the resistor. So equal to 20 volt.